Welcome back. Thanks for staying on tonight with us here on In Focus. The science of a flood interrogated tonight. What is the role of climate change in all this, that which we are seeing in KwaZulu-Natal, and should we brace ourselves for more? Climatologist Francois Engelbrecht joins us now to shed more light on this. Prof, good evening, and thank you very much for your time joining us tonight here on In Focus. I mean, to my mind, when they say flood, I'm thinking too much water in all the wrong places where it's not supposed to be. It could either be because of too much rain or otherwise maybe rivers or oceans that are overflowing. Is that the scientific definition, maybe, or a little bit more complex than that?
Good evening, Tabu. Thank you for having me. Well, I think your definition is close enough. Usually in the context of South Africa, a flood refers to an event where we have excessive amounts of rainfall that overwhelms the systems that we to drain away this water. So sometimes it is rivers overflowing their banks, sometimes it's a storm drainage system in a city that is overwhelmed. But the net result in South Africa is of flooding. Flooding in South Africa is almost always the net result of heavy falls of rain that occur within rather short periods, and it simply overwhelms the drainage systems.
Yeah. And what makes a flood deadly?
Well, let's explain that by what has just now happened in KwaZulu-Natal. We had absolutely excessive amounts of rain, record-breaking rainfall totals. Initially, during the first 24 hours of this heavy rainfall event, we had more than 300 millimeters of rainfall occurring over a large area, from as far south as Margate, along the KZN south coast, all the way through to the north of Durban. Now, for many of the weather stations in this region, this is the long-term record of rainfall that has been set. In the case of Margate, it's in the order of twice the previously set long-term record of rainfall for that specific location. So, of course, we've also had a wet season. It was a so-called La Nina season in South Africa. Across our eastern interior regions, the swells were already saturated by the time that this extreme weather system started to affect us. So that means all the precipitation, or much of the precipitation that reaches the surface, doesn't sink away into the swells. It immediately becomes runoff. And from there, it then finds its way often through storm drainage systems, or also systems that are not functioning as they should, into the rivers, and the river banks eventually overflow, and we have a major flood event. Yeah. So we should take notice of the fact that this was an absolutely exceptional rainfall event, but it's important that we also realize that very, very similar events have happened in the past. Many of the viewers may recall that almost exactly 3 years ago, during Easter weekend of 2019, we had a very, very similar event affecting Durban and also deeper into the KwaZulu-Natal Midlands. Yeah. 70 people died in the flash flooding and the mudslides of April 2019. That really should have been an early warning for us of how vulnerable we are for these excessive rainfall events. But unfortunately, 3 years later, we've now suffered an even larger tragedy in South Africa.
Yeah. What actually happened in KZN? I mean, what we are seeing, as you mentioned, mudslides, but we're also seeing roads caving in. Of course, I mean, we're also seeing buildings in that instance crumbling. Are all these related in any way?
Yes. Remember, I'm a climatologist, not a build engineer, so I can't give you the best possible answers for the question you've just asked. But I think what we have been warning, I've just, I guess by coincidence, 2 weeks ago, warned against the vulnerability we have in KZN in terms of the buildings that we have on steep hill slopes. Now, that goes from commercial buildings to informal settlements against steep hill slopes. For as long as we have these types of constructions in KwaZulu-Natal, I've written 2 weeks ago, we will have to be prepared to suffer these further damages and also, unfortunately, loss in human life, because we are extremely vulnerable for mudslides when heavy falls of rain occur against these steep hill slopes in KwaZulu-Natal. Now, on some of these slopes, I understand from engineers and people working in the built environment that you can safely build buildings along these slopes if you really know what you're doing, but it's very clear that we don't. And we have an immense vulnerability in KwaZulu-Natal, and I'm afraid for as long as these type of structures are in KwaZulu-Natal and people live in them, the hard reality is we are going to see this very same type of event repeating itself again as we go deep into the future.
From a weather point of view, then not so much on the build. Is the province prepared for this type of weather system in the future?
Toby, that's a really important question. And I think, the current state of affairs clearly shows us that we are not prepared. But the problem is that these types of events are just going to occur more frequently and at even greater intensity as we move deep into the future. This is a consequence of climate change. So having 2 of these really high intensity rainfall events in just 3 years is a real red alarm that should be ringing in our ears. We also had in 2019 Tropical Cyclone Idai, the worst weather system that ever hit Africa south of the equator in recorded history. More than 1,000 people died in Mozambique, Malawi, and Zimbabwe in the flooding caused by that cyclone. In a warmer world, storm systems are becoming more intense. It's firstly because there's more heat available, there's more energy available for the atmosphere to build really intense storms. But also the warmer we make the atmosphere, the more water vapor the atmosphere can carry, and the more water vapor is eventually available to form clouds and eventually rainfall. Now, the Intergovernmental Panel on Climate Change, just last year in August, stipulated clearly that in the eastern parts of South Africa, we can already detect a long-term trend of these heavy precipitation events occurring more and more frequently. It's clearly documented for our region. And therefore, climate science should really be helping us. We have a really good idea. We have high confidence that this type of event will just occur more and more frequently into the future. And we need to start to really rethink how we react to the early warnings of these events that are issued by the South African Weather Service. That is one thing that's working. Numerical weather prediction is a wonderful tool for us. It is very effective in giving us warnings of 2 to 3 days ahead of time of where and even when, exactly when in terms of the time of the day or the period of days, we can expect these types of flood-producing rainfall systems to occur. We need to really learn how to evacuate people to higher ground, to safer spaces. We are going to increasingly need that in South Africa. And I think the big problem here is not the early warnings. They are being issued, and they are being issued timely. The question is, how do we ensure the uptake of these warnings in our communities?
Yeah, an evacuation plan, many have been saying. But let's talk then about the risk in, for example, landlocked places like Johannesburg, and whether or not if there's any relationship to the frequency and maybe even the severity of the weather system in coastal areas.
Yes, there are also risks of a variety of risks of extreme weather events that can affect South Africa deeper into the interior. Let me first point out that in terms of flooding, it is our coastal cities that are the most vulnerable. That's simply because the moisture source of these convective clouds that produce all the rain is it's almost always the warm Indian Ocean. So the viewers may be interested to know that there have been several events of similar intensity if we look far back into history. For example, in September 1987, there were also floods in Durban, in which about 350 people died. And in that specific case, we had 900 millimeters of rain occurring in 4 days. I'm just making that point to show that we've always been vulnerable. Even before climate change has started to make the systems more intense, we've been vulnerable for these types of events. It's mostly the coastal cities. Quebec, when it was still known as Port Elizabeth, in September 1968, 450 millimeters of rain in just 4 hours. So it's usually the coastal cities that are vulnerable. I think Richards Bay is extremely vulnerable because it's possible that the tropical cyclone, an intense one, can reach as far south as Richards Bay. Maputo is extremely vulnerable. Yeah. Now, these tropical systems, the system we've just had came from the Atlantic Ocean. It wasn't a tropical system. But tropical storms can reach as far south as Zimbabwe. We had tropical cyclone Eloise, I think January 2021, if I remember correctly, that moved as far south as effectively influencing parts of the Northwest province eventually. It moved into South African territory around Messina. Yeah. So we can get rainfall events bringing 200 millimeters of rain in a day as far west as Johannesburg or Pretoria. That's not impossible at all. But these areas they are vulnerable, but they are not as vulnerable as the low-lying coastal areas close to the warm Indian Ocean.
Yeah. Now let's stay a little bit in KZN then. Do floods work like variance? For example, if we say this one was indeed a big one, does it go to say that the next one will be slightly a smaller one, or will it be even bigger?
Thabo, of course, we don't need 300 millimeters of rain to have a flash flood or a flood. So, for example, the devastation caused in April 2019, during that event, we had rainfall totals ranging from 100 millimeters to 180 millimeters, depending on where you look in KwaZulu-Natal. So, we cannot say that the next flood-producing weather system is going to be even more intense than the last one. I mean, I think this record, I really hope it will stand for at least several more years. But because of climate change, the hard reality is that we will experience this type of storm system more frequently in eastern South Africa. And the systems are becoming more intense. So it's a clear and present danger. As I've mentioned, we need to become much better in converting early warnings into action. But the other thing we must do is to really adapt our way completely out of this vulnerability. Just by providing people with good housing, strong buildings that are built in safe places and at high ground, we can gradually start to eliminate this vulnerability completely from our communities. Really, in South Africa in this day and age, we should no longer have communities that live below the flood line. Their lives are immediately in danger when we have these heavy falls of rain occurring. And as I've mentioned, we really need to rethink about how we construct buildings along these steep hill slopes in KwaZulu-Natal, because we've now just had a repeat of the 2019 tragedy, and really it can be avoided completely.
Prof, we appreciate your time and thank you very much for sharing your knowledge with us here tonight on the focus of this subject. That is Climatologist Professor Francois Engelbrecht. When we continue